So a nice transformation question, and let us see what it reads. It says here that the following diagram shows three quadrilaterals, P, Q, and R on a square grid. Q and R are the image of P after it underwent two different transformations, right? So we're looking at P, Q, and R right there. All right, let's see the questions that they actually have for us. Questions are as follows. On the grid on page 9, draw the image of the quadrilateral P after a translation by the vector 10, -4, label it P prime. All right, so we're actually going to be executing this. All right, so we want to, so we're doing 10, -4, translating P by 10, -4. We're going to employ counting. So quickly, the translation that we're going to be using is 10 with a -4. That means we're going to be moving to the right 10 places and then down 4 places. 10 to the right, 4 down. All right. So let's move each point. For example, moving this point here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 4 down. 1, 2, 3, 4. That point becomes there. And basically, when I do that, I can just recreate the other shapes, right? So basically, this is going to be here. The next one is going to be there. So you're recreating that shape. All right. So technically, you could check another one. For example, you could check this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 1, 2, 3, 4. So you could see you would move all 4 points, then recreate the shape. All right. So let us look at what the shape looks like, right? All right. So we have P prime right there. All right. Let's go to see the next question. Next question says, reflect P in the line y equals 0. I want to label it P double prime, right? So let's go back. We're going to reflect it in y equals 0. Y equals 0 is the x-axis. Y equals 0. And that's the x-axis right there. The concept about a reflection is that the object is and the image, they are equal in distances from the mirror line. The mirror line here is the y equals 0 line, which is the x-axis right there. That's the mirror line right now. So what we're going to do is to just do a quick counting. Let us see how many units is this point from the mirror. It's 1, 2, 3, 4. So it's going to fall 4 units below. Let's go. 1, 2, 3, 4. So I'm having it right there. And every other point will follow the same pattern. How far it is from the mirror, and then it's going to go behind it just the same. Let's go. 1, 1 right there. Then 2, 3, 4, 5, 6 to the mirror. So it's going to fall 6 below. 1, 2, 3, 4, 5, 6. All right. So the next point is right here. And then you could start seeing the other shapes coming out like that, right? So we could exactly what you will be doing for each. Let's connect this up to look at what we have. All right, so we're gonna label this P double prime. All right. So there it is. We would have followed through, exercise that. Let's see what the next question is about, right? Next question. So the next question says here, it says, describe fully a single transformation that maps quadrilateral P onto quadrilateral Q. So we're moving from P to Q, P to Q, P to Q. So we're talking about this P to Q. All right. Now, the moment the size of the image changes, it's a dilation, what we call an enlargement, right? So it is definitely an enlargement. So we need, for an enlargement, there are a number of things that you want to list for so it is an enlargement already because the size changes. It's an enlargement. We want to know the center of the enlargement, and we want to know the scale factor. So when you're describing an enlargement, you only need to find the center and the scale factor. If I have an object and an image already, to find the center of an enlargement, what I'm going to do is to draw a line through two corresponding points. For example, this point down here correspond with that point right there, right? So you're going to draw a very long line through them. And I'm referring to the fact that, look, they correspond with each other. This point correspond with that, right? And then I'm going to just find any other. So you just need any two pair, just two. So I'm going to connect this one to that, right? The moment you connect a straight line through two corresponding points, and you can see again that this point here corresponds with that. The moment you do that, wherever they intersect each other, so you could see the intersect is right here, they intersect right there. So the moment they intersect, right where they intersect is the center of the enlargement. And if I should read off that coordinate, it's -10. -10 with 7 is right there. -10, 7. That's our center, right? -10, 7 is the center. All right. Now, another thing that we want to do is to find the scale factor. To find the scale factor, you can look on any two relative corresponding ideas from the image and the object. For example, I can simply look at the length of that side and the length of that side, like looking to see how many diagonals it actually cross. You could see, and I'm going to show you, like this is any idea that you're seeing. Now you could look, it is could cross one box here that would say 1 square 1, right? And this side cross, so this cross one diagonal there, and this one crosses 1, 2, 3. So it crosses to 3 of those diagonals for the square. We can use that. You understand? So you could see that since this is the object and this is the image, then you could see that the scale factor is 3 because it's tripled, right? And there are other things that you could have done. There are a number of things. I just pick on one idea right there, but there are a lot of things that you could have picked and then use it to sort out that sort of problem. So here it is. It's an enlargement with a center of -10, 7, scale factor 3. Let's write up that part of the solution. So this is an enlargement. And I could say that we have the center, -10, 7, and that's scale factor was 3, right? All right. So we want to look at from P to R, right? P to R. So I went ahead and did the background work behind from P to R. So here it is. All right. So what we want to do is to quickly highlight some ideas. Firstly, we are observing two shapes. We're observing this shape right here, this one here, right? We're observing that shape there. And we're also observing this one right down here. Now, when you look at these shapes, you are realizing that it's not an enlargement because the size didn't change. It's not a translation because the orientation of the object changed. It's not a reflection because it's not laterally inverted, right? Now, because of that, we are now left with a rotation, and you could see that it was rotating, because if you should look at this point here, you're seeing it here. So it's like and then this point here is underneath here, and you're seeing like it is going in this direction. It went in sort of that direction, like it was going in that anti-clockwise direction. So firstly, I would note that this is a rotation. It's also going in an anti-clockwise direction. Anti-clockwise direction, right? And so rotation, anti-clockwise direction. So we need to know the degree, and we need to know the center of the rotation. In order to find the center of any rotation, what you want to do to find the center of the rotation is this, right? You want to connect a straight line between two corresponding points. For example, this point corresponds with this. I'm putting a straight line through it like that, and you bisect that line. So when you bisect that line, right? When you bisect that line, you're getting this for it. When you bisect that line, this is the bisecting line. And then you connect another pair of corresponding points. For example, this with a straight line. Bisect that again. And wherever the two bisecting lines intersect each other, that is the center of your rotation. And you do notice that they did cross path right here. Right here. This is where the two lines cross path. You could zoom it up and look, right? So it means then that the center is -4, 2. That's the center of that. So it's a -4, 2, right? My center is a -4, 2. -4, 2. And then if you want to see the degree, this is a 90 degree. This is a 90 degrees. There is a quick idea that you could look at, that if this is the quadrant 1, quadrant 2, quadrant 3, quadrant 4. If you're in quadrant 1 and you go 90 degree in any direction, it goes to the quadrant next door. So if I'm going this way, it goes that, it will stop in 2. If I'm rotating in the other direction 90, it goes here. If you're in quadrant 2, of which this is in quadrant 2, and you rotate 90 degrees anti-clockwise, expected to be in quadrant 3, you're seeing it in quadrant 3. All right. So that's one of the things you could quickly look to know the 90 degrees. But you could also do this. All right. We could also take a quick look at it here. Let's go back to this. Now we could look at the angle. So it's a rotation and everything, but we could look at the angle here on this diagram here, right about now, quickly. So we have already decided that this is the center. The center is right here at 4, -4, 2. So let us connect corresponding points to the center. For example, this to the center. If you connect corresponding points to the center, and this to the center, you'll see that 90 degree angle coming out. Take a look at it. Take a look at that 90 degree angle coming out right now. You're seeing that this is 90 degrees right there. And you can any two corresponding points. So if you, as long as you connect the two corresponding points to your center, right, definitely you will be seeing the angle, right? So it's -4, 2, which is right here. So you could see, you connect that and you're seeing that degree coming at you there, that 90 degree rotation in an anti-clockwise direction, all right, about the center, -4, 2, right? There we go. All right, so that's that. All right, so that's that for that.